Can you guys hear me? Okay. Good? So first of all, good morning. Did you guys have a good session and good time yesterday at the first day of the Public Sector Summit? Yeah? So before we kick off, a couple of housekeeping items. So exit in the back. Restrooms are located through the door and to the left. And then we ask that all participants and attendees today take a few minutes to complete the survey at the end of this session. Okay? Sound good? So welcome to our session today, a tale of two IT modernization strategies. My name is Keith Brooks. I am Senior Manager and Head of Business Development for AWS GovCloud US. And we want to welcome you to our session today. If you've seen any sessions that either me or someone from my organization has given either at past public sector summits or at other AWS summits or even at reInvent, you've likely picked up on a few themes that we'd like to discuss, particularly as it pertains to public sector organizations or private sector organizations in highly regulated industries. And one of those themes that we've talked about a lot is how a lot of public sector organizations are not only using cloud, and specifically AWS and GovCloud, to realize some of the cost efficiencies and scalability and flexibility benefits of the cloud, but increasingly these organizations are turning to AWS and GovCloud to drive IT modernization, IT transformation, and innovation within their organizations. And specifically for those customers and those organizations that have sensitive data, highly regulated workloads, or more stringent compliance requirements that they have to meet. And today during our session, we're going to hear from two of our customers that will explain how they approach IT modernization for those use cases. So I'm going to turn it over to a customer now. We have two customers, one from the Department of Justice, Bureau of Alcohol, Tobacco, and Firearms, and another customer from the U.S. Department of Veterans Affairs. And we're going to kick it off with ATF first. So I'd like to welcome Mason McDaniel, CTO of the Department of Justice's Bureau of Alcohol, Tobacco, and Firearms. Mason.
Thank you. I cannot tell you how excited I am to be here today. Not because they asked me to come speak to all you wonderful people, but because of how far we've come. I'd like to take a few minutes to talk through the hole that we found ourselves in with ATF's IT, the challenges that we knew we were facing, the strategies that we came up with to address those challenges, and of course, where are we today, and what have we learned along the way, both good and bad, that I can share with you to hopefully help you at least avoid making the same mistakes that we made. All of us, when we start out with any kind of an IT modernization effort, have an initial fundamental challenge, and that's how do you convince the executives, who are often non-technical, to take money that could be spent on body armor, vehicles, ammunition, things that directly, tangibly, obviously support the law enforcement mission, and spend it on invisible IT. They can log into their systems today, they work. Why invest a lot of money in something that they can't see? And I found that you cannot make that case in technical terms. You have to make that argument in business terms. And the most effective approach that I've found for making that argument is around the concept of technical debt. And that's a concept that arose out of the software development industry, but really has broader application across IT to refer to any work that needs to be done to keep an IT system working the way that it should be working that has been deferred, that has not been done. And on average, rule of thumb, about 30% of the cost to make a system in the first place is required annually in maintenance costs to adequately maintain and keep that system operating. When that money is not provided for the ongoing maintenance, you begin accumulating technical debt. And that can grow into a barrier to modernization that can ultimately leave your system so old, so antiquated that they effectively cannot be updated, leaving total modernization, total replacement as the only viable approach. So I'd like to take a few minutes to talk through some specific examples of technical debt that we found ourselves with at ATF and sort of how we communicated them in business terms. And the first one, and you may be wondering what snow on my back deck has to do with ATF's IT, but the day that happened, We got 38 inches of snow at ATF's data center, and we had to evacuate the building for 2 days because the structural engineers were concerned the building wasn't rated to support the weight of that much snow on the roof. It's a one-story building. If that roof had collapsed, all our systems would have come offline. 3 years before that, we had accumulated a significant amount of technical debt when we closed our disaster recovery site and moved the disaster recovery instances of all of our systems into our primary data center, largely for cost-cutting reasons, but the money that it would have taken to maintain that disaster recovery site was technical debt that we accumulated by closing it. Had that roof collapsed, all ATF primary systems and failover systems would have gone offline with no estimate for when we would be able to recover them. In 1996, I worked at the Commodity Futures Trading Commission when they installed their first high-speed, high-bandwidth T1 connection to their headquarters. In the 20-plus years since then, average home bandwidth has increased by over 2,000 times. Up until about last year, that exact same T1 connection was what fed most of our ATF offices. Applications have been developing and advancing over time, assuming at least the level of connectivity that people have at their homes. So our agents, our analysts were spending a huge percentage of their time staring at the spinning wheel of death. Shortly after I joined ATF, I went to one of the field offices, and one of the managers there told me that when they have an urgent deadline, they would often send their agents home to work from home because they could get better performance connecting in through their home networks, through the VPN, than they could through ATF's networks. Now, our average data center server is over 10 years old. They've been out of maintenance for many years. The spare parts, spare supplies are dwindling, and the rate of failures is increasing. We can't buy replacement parts for them, so we're facing a major capital outlay to do either total data center hardware refresh or take that money that would go into the capital expense of the hardware and spend that toward a cloud modernization strategy. And incidentally, as a tangent, our deputy CFO grumbled in a meeting one day about these newfangled smartphones, and he just wanted his BlackBerry back. So I arranged to show up early the next morning. That's his desk. I replaced his laptop with a 486 running Windows 3.11 for work groups, a BlackBerry on the dock, a full size and a pocket slide rule, and a couple of 1980s magazines about the newfangled financial applications. I will say that is the happiest I have ever seen that man. He spent almost the entire day giving demos to any executive he could get to come by his office about the advanced new technologies that I'm bringing to ATF. Our official enterprise reporting application is one that was retired by the vendor about 5 years ago and has been unsupported. When we upgraded our laptops to Windows 10, it broke, and we lost the ability to report on our data until we were able to find some Band-Aids, baling wire, bubblegum solutions to get that system up and running. We don't know when Windows is going to put out a patch that breaks that system again irreparably, and we will lose the ability to report on ATF's data. And we likely won't know that until after it's happened. So we have to begin an effort, and we have one underway, to implement a new reporting system. We had an application that was very well received, actually, by the firearms industry, and the director decided he wanted to make a copy of that capability and provide it out to the explosives industry. Pretty straightforward. As a Java application, we hired a Java developer, handed him the source code, and he almost immediately came back and said, "This is going to cost more and take longer than I'd expected because I have to learn the language." And our initial thought, clearly we hired the wrong person. But turns out it was written in Java 1.4, and Java 12 is out now. There are no manuals that you can buy for Java 1.4. There are no online forums you can go to ask questions. He had to relearn, reverse engineer the language out of the source code, and that is a very time-consuming, labor-intensive effort, which really raises an important point. Very much like financial debt, technical debt carries interest. In general, the older it is, the more time and money it takes to work off. And one of our core mission application portfolios is built on a browser plugin technology that is obsolete. 4 out of the 5 major browsers have already dropped support for it. So it runs in one browser, and that browser is going away. So we have until that browser either drops support for it or goes away to rebuild that application portfolio on a different technology stack, or we will lose that mission area and the ability to perform it. Notice every one of those has technical underpinnings, but every one of them is a practical, very real mission impact of not doing something to fix it, and that resonated. And we actually got funding to do a total IT modernization refresh of pretty much all of our applications. And we decided to start with what we saw as the most glaring, most fundamental, and high priority problem, our lack of disaster recovery. And we decided to approach that problem as an opportunity and as a potential cloud on-ramp. Because when we started out, all of our systems were in our on-prem data center. We had no effective disaster recovery. So that gave us an opportunity to start looking at what is it going to take? How do we build a failover copy of all of our systems in the cloud? Use that as our disaster recovery site. And then once those are mature, once those are proven out enough, we can switch primary and failover and service our users out of the cloud as the primary infrastructure with our on-prem as failover. And then we can do region-to-region replication, and we can do entire cloud-hosted environment for primary and failover, and we can shut down our data center. Now, we knew going into this that we were going to be facing quite a few challenges, not the least of which is just the fundamental difference between managing your own physical infrastructure, wiring, cabling, you control it all, to virtualized infrastructure as code, having to design and understand the new networking, how do you secure it, how do you monitor it, just all of this stuff. And even when the capabilities are better, it's still a learning curve. So we knew that was something that we were going to have to face. Also, 70% of our systems ran on Spark Solaris. That does not run terribly well in most clouds. So we already knew that we were going to be refactoring a lot of our source code, and we decided that we were going to refactor it over onto a Linux platform. At the same time, we're also going to be migrating our data over to a different enterprise database platform. And we were under time pressure, and that's my desk clock just to represent time. There's a data center consolidation initiative, and we were under a deadline of December of 2018 to shut our data center down. And spoiler alert, we didn't make it, but I'll come back to that. The most pressing, or the biggest challenge that we faced, though, was what we refer to as the ATF hairball. That is the interconnections and interdependencies between all of our core major mission applications and databases, which are not nice, clean API to API abstracted interfaces. Many of them are direct calls, direct data access to other databases. They're very tightly interwoven together, which is why we have a poor track record at the ATF of trying to pull out individual systems and modernize them in isolation. So we decided we need a different approach. How are we going to tackle the complexity here and find something that will work for it? We did pull aside like the case management applications. They spent about a year doing business process reengineering, figuring out how do we want those processes to work and be more efficient. And they're rebuilding those in a low-code, no-code environment. They're doing those right. We can't do that with 70 applications. We can't do that with all of our applications at once. It's too many moving parts. So we decided to reduce the risk some. Our focus is going to be pay off the technical debt first. We can't update, we can't do anything with our existing systems because they're so old and they're not really supportable or maintainable. Let's get all of our systems up to a common technology baseline where we can start. It'll essentially get us to the starting point where we can start doing business process reengineering incrementally, continuous improvement, updating those business processes and technologies from there. So instead of doing that vertical slice like we'd always tried before, we decided to take a completely different approach and instead tackle it by tier. And we analyzed every ATF database, went through the data types, mapped those over to the new database structures, and then migrated all of our databases from the development environment to the new AWS development environment, from test to test, and our production environment to our new AWS production environment. And we got a full ATO, got it turned on, and approval to operate in our nice, shiny new AWS environment without a single app on it, with just the data. So now, as we go through refactoring, application by application, all of those other systems that it had dependence on for access to the data, all that data is already there. So now we were pulling all of the embedded proprietary PL/SQL code out of the database. We're rebuilding that into a data access layer to help abstract the data tier and make it easier for us to update that and make changes in the future. All the business logic we're consolidating into business modules to try to make it easier for us as we enter that continuous improvement mode to start doing those API to API calls, automate some of those steps that are currently manual. And over time, as we go through each of these, it's setting us up with the same basic functionality we have today, but the technical debt paid off on a modern platform that is going to make it much easier for us to then do the business process improvements that we want. Now, technology is not enough. First of all, the only way you can handle that kind of change and that much change in a short period of time is through automation. You have to automate everything you can, whether it's automating the infrastructure deployment, automating your testing, automating your software builds and deployment. Everything has to be automated. But it doesn't do you any good if you can build a virtual machine or a container in 5 minutes if it takes you a month to get it through your change control processes. So just as important as building your new infrastructure and building those automation technologies and rewriting your source code, you also have to rewrite your governance processes to enable the new technologies and the new efficiencies. So we did that, and we've been going through a wholesale rewrite of our governance processes centered around the ideas of continuous improvement, continuous deployment, automation. Now, what are some of the core lessons learned that we've found going through this? First of all, was that initial lesson, you've got to make the case in business terms to justify the funding and be able to get just the executive buy-in. More than just the funding, the availability of testers and a lot of those other peripheral players that you need to make the modernization work. You have to automate everything if you want to do anything at scale, at any large volume of change within a reasonable period of time. And you can't enable that automation if you don't revisit your governance processes. And we spent about a year looking at our existing very old processes, trying to figure out, how do we update these? How do we edit them to allow these new technologies? And we eventually decided it was just a bridge too far. They were too fundamentally different. And we set it aside. We started from scratch, blank page, and started writing a new set of governance processes, consistent with DOJ's configuration management and all of their governance framework, but a new set of governance processes for ATF centered around automation and CI/CD. Now, this is going to shock all of you, I know, but unless you are already mature in your use of automation and continuous deployment, your baselines are wrong. I don't know anything about your systems, but I guarantee it, your baselines are wrong. You cannot keep them up to date through manual processes. So we really learned that as well. So we started out with everything that was in our configuration control system, and that was sort of what we did our assessments around. And I'm going to come back to that in a moment. I know we have a lot of people from out of town, but we have a lot of locals here. Is there anybody here who has driven across the Arlington Memorial Bridge here in DC? Quite a few of you. That is the Arlington Memorial Bridge in 2015 before they shut it down for emergency repairs. It was functioning just fine as a bridge. People were driving across that every day. You were probably driving across that. And it was working just fine. But nobody knew how broken it was under the deck. That was ATF's applications. We found when we actually went in and started refactoring, rewriting the code, that I had made a fundamental mistake when we first started out this process and we were We had the theory, take today's systems and rewrite that source code in a modern technology framework. I made the mistake and the assumption that our applications actually worked. We found that over the 10 to 15 years that some of these applications have been around, they had tried to update them over time, largely not successfully, but they left the source code in. That didn't work. And one of our applications, 80% of all the source code in the system had never worked. So now we have a base of source code, and our challenge is rewrite this source code. 80% of it has never worked, but make sure what worked before does. And by the way, we can't tell you which 20% worked. That is a very different problem and is much more difficult and is much more iterative. It requires a lot more building stuff, going back, verifying, and it is a much slower, more intensive process. Our employees are creative and are driven, and they will find a way to get the mission done, and they did. When those previous development efforts did not succeed, some very creative employees found some workarounds and found some ways to do what they needed to do. And some of those workarounds involved SQL scripts that somebody wrote, and it turned out there were hundreds of these. Some of them 10,000 lines long or longer, that directly accessed the production database and ran queries, made changes, and they passed those across the users and analysts, and those became part of the official business process. And of course, run as SQL scripts against the production database. There was no auditing or control of that, which is a really terrifying concept. But beyond that, evidently either that person or people, I don't know who did this, decided one of the database text fields was not required anymore, and they decided to write an entire XML file into that text field. So those SQL scripts also read that XML file, performed some logic, changed things, and wrote it back into the text field. So that became a part of their official business process, which again is scary because if one of those executions failed, that could corrupt the XML file for everybody and break things. And then just for those situations where they couldn't do what they needed through all of those, they gave a database administrator tool to the non-technical analysts to log into their production database, pull up the particular data tables and fields, and edit them directly to carry on the steps that they didn't have the software to do. None of that was in the baseline source code, and none of that was in our initial plans. So now we were facing a quandary. We had come into this saying we're not doing massive business process enhancements, we're building like for like. What we have today, we're going to build in AWS. Once we discovered that, we can't give database administrator tools to our analysts. We can't reproduce that in our new AWS environment. At the same time, we can't go back and recreate 10 to 15 years of desired functionality that they wanted. So we wound up settling on that middle ground where all of the workarounds that they built and incorporated into their core business processes, we would absorb and we would build those out in the application framework along with the other functionality. So that added a significant amount of new scope to our project and is why we did not hit that December 28 date, December 2018 date. So where are we today? We have built the continuous integration, continuous deployment environment. We've put out the automation tools for the automated testing, the software continuous integration, deployment, containerization, and we are using that for developing the new versions of the applications. We have migrated our databases into AWS at all tiers, dev, test, and production. We have a draft of the new governance framework out for review and feedback. And there are still a few sections that are placeholders that we need to fill in, but the core framework is there. So that's out for review. And in terms of the migrations themselves, we have 7 core kind of back-end enterprise services like Active Directory, identity, things like that we have migrated that are running production out of AWS. We have 11 applications that are running Switch Now production out of AWS. We have shut down nearly half of the servers in our data center. And of the applications that are remaining to be flipped over, about three quarters of them are in user acceptance testing now, iteratively going back and forth, and we're fine. This is actually a very difficult process as well. Because once you get to the point of looking to turn on these applications, you get a lot of feedback. And anytime you're taking 10 to 15-year-old applications and rewriting them in a web framework, no matter how close you try to make it, you're going to wind up with some look and feel issues. So now we're trying to identify what are core functionality defects that truly don't work that we have to fix, what are some things that we can try to work on over time, and what are just differences in the underlying framework itself. Depending upon how long that process takes, we will switch over, focus on the remaining quarter of our applications, get those into the UAT, and then at that point, shut our data center down. And we're targeting fall of this year to reach that goal and actually power it off. So I would just like to close with one thought. The cloud can be a stormy place. It is not going to be a smooth journey. It is going to be bumpy at times, but stay the course. It is worth it, and we are already seeing the benefits from being in the cloud, and I am confident that you will as well. Thank you. And there you go. I'll let you.
Good job.
Thank you.
Good morning, everyone. Can you hear me? Okay, so I'm Dave Catanoso with the Department of Veterans Affairs, Office of Information Technology, Enterprise Cloud Solutions Office. Just some quick background. I'm from New Jersey, so I don't know if anybody else here is from New Jersey. But I spent some time in the Signal Corps as an officer after getting out of college. Worked after leaving the Army with 25 years or so in the private industry, both large and small companies. I joined the VA in 2011. And since about 2013, been working on cloud-related projects for the VA. And today what I'm going to do is provide you an overview of the VA's Enterprise Cloud strategy, give you kind of an idea of how we've implemented that strategy with the VA Enterprise Cloud. We're going to walk through a recent migration that we've done successfully with one of our major systems, the Veterans Benefit Management System, and explain how that's been a success. So first of all, for those of you who don't know, what is the VA? The VA, as is probably obvious, serves millions of veterans every day. And one of the first things I noticed when I joined the VA was just how large an organization it is. It's the second largest federal agency. We have over 368,000 employees, and we're organized into 3 major lines of business. The Veterans Benefits Administration provides loans, disability coverage, education, and other benefits to thousands and processes thousands of claims every day. The Veterans Health Administration is really one of almost the largest healthcare system in the world with over 170 hospitals and 1,200 clinics. And our National Cemetery Administration operates over 150 national cemeteries and monument sites. In addition to all that, the VA has the corporate structure above that to organize and operate such an organization, Office of Information Technology, Human Resources, Finance, Security, and other organizations just to support that. So we have to support all the IT infrastructure to make that work. As you can imagine, there's a lot of challenges that go with that, but I'm going to focus on 3 today. We have a definite need to increase innovation to deliver service to veterans, and to do that, we have to free up funding in order to fuel that innovation. And of course, while we get all that done, we have to comply with all the mandates and rules. We have to comply with federal rules, regulations, laws, and the federal mandate to go to the cloud. So what's our strategy? How are we going to get this done? We're really breaking it into 2 simple tracks. First, wherever possible, we're going to use software as a service, or SaaS. And in that area, for example, last year we recently completed probably one of the largest migrations to Productivity Suite that's ever been done. We migrated over 480,000 mailboxes to the cloud and are complying with OMB mandates in that area. We're probably one of the first agencies to get it done to 100%. We're also using software as a service for other major functions. For client relationship or customer relationship management, and our IT service desk is also all done in software as a service. And whenever we can't use software as a service, we've decided to pursue that with an enterprise cloud approach. And in April of 2018, the VA formed the Enterprise Cloud Solutions Office, and I've had the privilege of being its director since it formed. And our office has a responsibility for executing the cloud strategy, being a focal point for policy, enterprise acquisitions, providing a location and place where projects can deploy to the cloud and standard services, and help and assist those projects migrate, and also help new development in the cloud. So what is the VA Enterprise Cloud? It's a hybrid cloud environment with multiple cloud providers, and of course AWS is one of our primary providers, and we chose AWS because of its FedRAMP High certification. Most of our data is personally identified information and private health information, and that's got to be kept at the highest level of security. We take our veteran data very seriously. And in that cloud environment, we provide access to all the CSP services, in this case AWS. We also provide a set of common shared services to make application migration and development easier, so application teams don't have to duplicate all the same things over and over again. We provide them as a common service. So let's drill down a little further, take a look at what we built. So this is a picture of our overall AWS environment. We use both AWS Commercial and GovCloud. We use the commercial environment for lab environments, mainly for training, to test out design patterns or software that isn't approved for use on the VA network. And then most of our work is done in the Amazon GovCloud, and that's where we've initially built out all our shared services. We started out building everything in GovCloud West, and now that GovCloud East is available, we're rapidly expanding into that region as well. In the GovCloud, we also have a lab environment where we position projects developing to go to production. And GovCloud is where we installed, like I said, all the shared services. So we've got source control tools, security scanning tools, logging configurations. We use Amazon QuickSight for reporting to help applications track their usage and cost data. And we've also deployed VA Active Directory as a service into the Amazon GovCloud. And as you can imagine, VA's Active Directory infrastructure is probably one of the largest of its kind. And by replicating that into the cloud, it not only provided a major redundancy for our Active Directory, it makes the performance of our applications running in Amazon much better. And we leverage also Amazon's Direct Connect. One of the challenges we had at the VA, whenever we set up an external connection, it was a long and arduous process to connect external environments. So by using Amazon Direct Connect to put a permanent connection in between the VA network and the Amazon cloud, we've got now a fully redundant, high bandwidth, encrypted, TIC compliant connection that all the applications can share, and we don't have to go through that process every time. Another key benefit of this structure is that we get to inherit the security controls from the Amazon FedRAMP certification to build our authority to operate, or ATO, for the enterprise cloud. And then we also add security controls on top of that our applications get to inherit. So it rapidly or greatly increases the speed with which we can get applications ATO'd and into production. So what I'm going to talk about now is really one of our major success stories of migrating the Veterans Benefit Management System into the enterprise cloud. So as I mentioned earlier, VBA provides services to millions of veterans in the financial area, and VBMS is the tool they use to get that job done. So it's a custom web-based application, basically providing paperless service. It's only 8 years old, and it supports 4,000 concurrent users, and serves up 800 million documents on a daily basis so that claims can be processed and reviewed by claims reviewers to approve and adjudicate claims. And every day, thousands of documents get added by scanning vendors around the country that are processing claims for the VA and adding to that document repository. It has to be available 24/7 and serve VA users from the East Coast all the way out to the Philippines. So why migrate VBMS to the cloud? It's only 8 years old. Well, the problem is it was very expensive to operate, and it was actually literally running out of space in the data center for document storage. So as part of VA's IT modernization strategy, we're doing things to improve our data handling, improve security, digitize our processes, and decommission legacy systems and migrate those to the cloud. And real goal is to promote flexibility and cost savings, again, to fuel innovation to serve veterans. So let's take a quick look at how the architecture looked prior to migration and then shortly afterwards. One of the things we tried to do during the migration, because it was such a complex system, was to keep it simple and minimize the number of changes we were going to make. And so I'm just going to highlight a couple of the key changes. One of the things that was in the old data center, we leveraged a system called FileNet to store those documents. And instead of replicating FileNet on IaaS inside of AWS and that transporting essentially one for one that architecture, we took the approach of converting and creating a document broker layer to move all of our documents into Amazon S3. And then second, in the data center that was in previously, there were limitations on the size of the VMs that we can provision. And so therefore, in order to get the performance we needed, we had to use something called Oracle RAC. But Oracle RAC is not supported in Amazon GovCloud or Amazon at all. So the good news is that the EC2 service provides a much wider range of VM sizes, very large VMs, and we were able to leverage that capability to actually meet the performance requirements using standard Oracle databases. So how do we get it done? What was the approach that we took? We really broke the plan into four main tracks that operated in parallel. So we started early on just planning how are we going to make this document broker layer work and testing out whether we could make the change from FileNet to S3. And once we determined we could do that and got started, it was about an 8-month process to execute these 4 tracks successfully. So track 1 was to take all the new incoming documents and stop putting them in the old data center, put them directly into Amazon S3 and start to use it as a giant hard drive in the cloud to store these documents. Once that was working, we went to track 2, which was to leverage that same document broker layer and start taking all the existing documents and migrate them, 800 million of them, from the existing data center over to the Amazon cloud. And what we did there is we used Snowball. So if anybody's looking at a good way to move data in large bulk, I would definitely look at the Snowball technology. And then once we had that in progress, we started moving our development environments and really building out an infrastructure as code capability to help us with track 4, which was to move all the exact application themselves over to the new cloud and get them set up and operating. And by executing those 4 tracks in parallel, we were able to successfully cut over VBMS in the Amazon cloud on May 5th of this year. So how did that work out? The actual migration and cutover was very smooth. The day that we did it, we didn't really have any issues. And that Monday morning when the system really turned on and users started accessing it, we were very rapidly supporting 3,500 or more concurrent users and providing generally faster performance than we had seen in the data center prior to migration. We did actually run into a challenge, though, shortly thereafter, where users experienced a lot of latency or slow download times on large documents. As you can imagine, when you're adjudicating claims, you have to review lots of document and paper files, and the longer it takes you to download each document to review it, it just cuts down your throughput and the number of claims you can process. So that was a major concern for our business customers. So we rapidly assembled a Tiger team from AWS, the VBMS team, our team, and our IT operations team to analyze the whole network path and look for areas where we can make improvements. We made some adjustments to our cloud service routers that improved throughput, and then we also did some other adjustments that I'll talk about in a minute that basically enabled us to take a prior download time, which was acceptable prior to migration, at 2 to 3 minutes for a 100 megabit file, and by the time we were done optimizing, we had a sub 1 minute download times on a consistent basis, which made the customer very happy. So that was a great success for the team at that point in time. So what did we learn through this giant process of migrating this huge application to the cloud? First thing, you're always going to improve. So throughout the entire process, we were getting lessons learned and feeding that back into the process to improve what we were doing. Some key takeaways is I recommend everybody do is always leverage infrastructure as code. It greatly simplifies what you're doing once you have it set up, and it creates repeatability if you have to do things a second time. Another thing is when you're using Snowball to migrate data, it's great for large files, but we learned very quickly that the overhead associated with small files can really, if you have a lot of them, would really slow down the ingestion of that data into AWS. So for those, we decided to transmit those over the network and focus on the large files going with using Snowball. And then, as I said before, dealing with that file download side, one of the things that we discovered was a challenge is that there's a limitation of 1.25 gigabits per second on a VPC gateway. And that was actually causing a problem as the throughput of bringing those documents down, we were bumping into that ceiling. So we were able to solve that by using VPC peering with other customer workloads for VBMS that were already in the Amazon GovCloud and send some of that traffic using VPC peering. And then we also added VPCs and did some horizontal scaling. And by using those 2 techniques, we achieved that huge reduction in download times and solved that problem. So early on, VA's cloud strategy was you can see we have very little usage of AWS in the beginning because we spent the time up front establishing that common area, landing area or beachhead as we used to call it, in the cloud where we were building out common services, setting up the security controls, basically getting ready to receive applications. And we migrated a few small applications to gain confidence. But now that we're up and running and we really are building that confidence, you can see the rapid increase in usage where we've almost got 2,500 VMs now, probably, but that was in April data, so by now we're probably over that, probably almost closer to 2,700 or 3,000. And then we've got almost 3.5 petabytes of data in storage at Amazon, and that's rapidly growing. So the VA and VBMS moving to the cloud, that's an internal-facing application, but really, VA is also moving some of its most critical veteran-facing applications to the cloud as well. The Digital Veterans Platform, vets.gov, va.gov, and MyHealthyVet are all now operating in the VA Enterprise Cloud. And one of our next challenges really is to bring the VA's Electronic Health Record System, or VISTA, to the cloud. And we've got a pilot project in progress on that now, and we're expected to launch that first pilot site at the end of the month. And just recently, on the anniversary of D-Day, June 6th, the VA launched the Mission Act, which is a program designed to improve veteran care by providing access to care in their local communities. And one of the main tools of that Mission Act program is called the Decision Support Tool, which helps doctors find care for veterans locally. And that tool is now running in the VA Enterprise Cloud. It launched successfully on the same day. So in closing, I'd like to recognize the VA senior leadership, and their guidance and strong support really is the only thing that made this possible. Without that, we wouldn't have been successful. I'd like to thank the entire ECSO and VBMS teams, as well as our partners in IT operations. Without all their hard work and very long hours, we wouldn't have stood up the VAEC or been able to migrate a program as complex as VBMS successfully. And of course, I want to thank our Amazon account team. They've been with us every step of the way, and without their support, we also wouldn't have been able to succeed. So thank you very much, and I hope everyone enjoys the rest of the event.